Now let's have a look at the graphics display. If you get into the resources section, you'll see that there is a Logisim file. So you can go ahead and open that up, and it's got all of the updated circuitry for the graphics, which we will talk over through the next few videos. Now this is the graphics section here. What I've done is I've taken a copy of it and I've stuck it into the main section. So let's talk through what this unit is, and we can look at the inputs to this and the outputs onto the screen. So you can see here that if I was to click on the actual graphics here, you can see that it brings up the properties. So the first thing here to note is a blinking dot or a no cursor. Okay, so that doesn't bother us for the moment. We'll just leave that as a blinking dot. And the second one, just leave that as asynchronous. For the moment, it doesn't bother us. Now, the thing we're interested in is the colour model. The colour model we're going to use is 565 RGB 16-bit. Now, we will talk a little bit about this in a different video, but that's the one we want to be using. And you can see here, it's got a width of 256. That's the one I've picked, which is the largest. And it's got the height here of 256 as well. So it really tells us that this unit here is going to be 256 pixels wide and 256 pixels of height. And you can change the scale in it as well to make it much larger physically on the screen or smaller. So I've got the scale of 2, and it gives us just a nice size to work with. Now, we have the reset button here, so I'll just talk from left to right. These are all of the buttons. So there's 1, 2, 3, 4, 5, 6 buttons that we can use. So we're going to have the reset here. So you click on this and it's all reset and ready to go. So there's nothing really difficult about that. Now we're going to have an X and a Y coordinate. So the X, as I said, is going to be 256 and the Y will be 256. So we've got 8 bits here representing 256 values. And we can turn them on just by choosing them. So let's say we wanted to put a little white dot in the centre of the screen. Then the centre of the screen is going to be halfway along in the X, which is roughly, well, it is 128. So if we click on this one here for the X and this one for the Y, it will go along 128 and down 128 and put a dot on the screen. But of course, you have to know what colour it is going to be. So again, we'll talk through the colour format in a different video. But right now, if it's all ones, then we're going to have a white dot. Okay. So you can ignore the little dot appearing at the moment because it's not really part of what's happening here. So if we want to, for example, have the dot appear on the screen, you can click clock in and you can see we've got our dot appearing. But of course, if we clock this again, it disappears, okay? And we can make it appear and disappear with this clock. Now, if we wanted the dot to stay permanently on the screen, what we can do is we can click this enable. So if we click the enable, it means that whenever we click this, the dot will remain on the screen. And then if we picked a different position for another dot, and then we click that clock in, then that dot there will remain on the screen. And we can keep doing this and we can keep putting the dots on. Now, if we were to leave this off, then the dot would only appear on the screen momentarily while the clock was running. So this would in effect give us the effect of a movement if we wanted that. But we're not going to use that for the moment. All we're interested in is having the enable set high, having a reset, an 8-bit X coordinate, an 8-bit Y coordinate, and a 16-bit colour. And we're going to have the clock in, which will clock in and out, and also the reset. So those are all our connections that we're interested in. So let's go back into the main panel, and you can see here, that's all we've got here. We've got these here, X and Y. This is actually our colour coming in here. We've got the enable sitting at 1. We've got our clock coming in, and we've got a reset. So it's relatively straightforward. Now, in order to get these two circuits working, I've had to change the some things round a little bit. So for example, we will talk about the clock. So the clock had to get redone. I'm talking about the main clock for the whole CPU, but I will cover the clock stuff in an appendix section near the end of the course. And there's a few other items that I had to update in order to get it all working correctly, but we will talk through those. So now if you head down into the computer, the section that we're interested in is actually here. So you can see we've got two cards here. We've got a graphics card 1 and a graphics card 2. So really they're split into two. I could have actually joined them together as one, but it generates a much more larger and complicated circuit, and they're doing two separate kind of functions, so that's why they're kept separate. Now the graphics card 1 here, it allows us to put actual dots onto the screen, and it allows us to use a command which I've generated called pixel, which will allow us to put dots all over the screen, all different colours, and we can write assembly language code which will allow us to do that and generate some nice effects. Now graphics card 2 is slightly different. Graphics card 2 is going to contain a RAM block, and in that RAM block we can load in an entire image which is going to be 256 by 256, and we can use that as a splash screen, so we can quickly download a picture onto the screen. So these are the two separate items that we have for the graphics. Now in this video what we will do is we'll talk through graphics card 1. Now I'll go up first of all and I'll reset it just so we've got a better colour. Okay, so I'll head down in here. Now it's relatively cluttered, but we'll take our time and we'll work through it, and it's much easier to see how it works whenever it's actually running. But I will talk through the actual design first of all, and in the next video when we see it running, you'll be able to see all of the lines coming on and off, and it will become quite obvious when you see that actually happening, how the section runs. So let's drop down inside here. So this is our section here. Now I'll make it a little bit bigger. Okay, so I think we've got, well that'll do, so I'll a wee bit smaller then. So this is the graphics card 1. Now we can actually break it into little blocks, so don't get worried if it looks all a bit confusing. So we've seen this block before. We know this block is the section that chooses the graphics card. Okay, so we've seen this before. Now these two blocks are just carbon copies, this block here and this block, and I'll actually show you these two little blocks running, okay, and you'll see what it is they do, and I will explain later why it is that they're actually doing that. So if I first set this up so that we can actually run the simulation here. So whenever I choose this control set, you'll see that the first clock pulse it chooses this one, and in the second clock pulse it chooses that one. Okay, so all this does is just choose one line or another line for each clock pulse. Okay, and this happens here as well. We do exactly the same thing. We choose, for the input here, we choose one clock, one line or another line. depending on the one input or the next input. Okay, so that's all these two do. Now we've got a couple of registers here, and these registers store one stores the colour and one stores the X and the Y coordinates. So the colour's a 16-bit value, which we've seen. Now the X and Y coordinates are both 8 bits, but they're going to come in as a 16-bit, and then we will separate them into the X and the Y. So this is where we separate the values into X and Y. And then finally we're going to have our output. So our output is going to be our colour for our display at the top level, our graphics display, and our X and Y coordinates. Now that's the basics of what each block is. Let's go ahead and we'll show you why it's built like this, and we'll see it actually working. Now I have generated a command called pixel, and in this command the very first term is the opcode, which is pixel, and then the next term is the memory mapped IO location for this device, which is FFF5, and then after that comes the colour, which is held in a register RA, and then an X and a Y coordinate, which is held in register RB. So for example, the command would look something like pixel FFF5 R0 R1. So R0, register R0 would hold the colour, and register R1 would hold the X and Y position. Now we will see this within the assembler and within the assembly language in a later video, but for now we just need to know what the format looks like. So it means that whenever this command comes along, it has to do three things. One, it has to choose this device, and it chooses this device via the FFF5, and we've seen the choice before, and this is a little section for the choice, so we can actually run this just now. So what would happen is the ID for this device would be, the last value would be 5, okay, and whenever the memory address register, the last values go to 5, then this line goes high, and whenever the enable goes high, if we check this out, you'll see that we get the bottom line here goes high, which takes this point high. Now that would only come on for one clock pulse, so whenever the enable goes low again, you'll see that the line in between here will go high. And it doesn't now matter what happens here with any of these inputs. We've now chosen this device. This line here has gone high. And you can see this line here goes up to two places. It goes to a set point here and a set point here. So this register here is going to hold the colour, and this register here has to hold the X and Y positions. So now you can maybe see the reason why we've got this circuit here. What we have to do is, we have from the command pixel, we have to read in the colour and place it into a register, and then we have to go and read in the X and Y coordinates and place it in another register. So it means that we have to set the colour in this register with one clock pulse, and then when the next clock pulse comes along, we have to set the X and Y position in this register. So now that we have chosen the device, we're in a position to actually set the values. So the control set is going to come in. So let's say this is the value for the colour. It's all the ones along here. Then whenever the control set comes in, you can see first of all it chooses the line here, which will set the colour in this register. And you can see both lines have gone high. They set it here. Now when this goes low, the value is now set in here. And what will happen is now the XY position will come in. Now when the XY position comes in, the next clock pulse, the other line here at the top will go high. and you can see that the X and Y position will now be set into this register. So that's the reason for having this little block here. It chooses one set for the colour, then one set for the X and Y position. So we've got both of these set here within the registers. Now, the next thing we have to do is we have to enable those values onto the bus. But we have to be careful because we've got two graphics cards and the output from the graphics cards actually go together in one line. And we can't have both graphics cards trying to access that line at the same time. So we have to have another point where we can choose or tell the graphics card that we want to output to the bus. Okay, and that's this little line here. And I'll show you where that comes from just in a moment. But if we were to now then click on this, you'll see that it unlatches this and it passes the value now on to the enable. So we are now at a point where we are ready to enable this onto the bus. But again, it won't be enabled until we choose this device again. But this choice, again, it happens within the microcode, so you don't actually see it. So it means that whenever this, again, enable goes high, and when we choose this device, you'll see that both of these been set, both of them have gone on, and the enables have now gone on, and we've passed the values to the output. So this will now go to the output, display at the top level, graphics display, and we will see the dot actually appearing. And it means that whenever these get turned off, you can see that we no longer have access to the bus. Okay, so again, the ID here would change, and it won't matter what happens here with these inputs. If we're not choosing this device, we won't get anything out onto the bus. So that's the basics of how this works. I suggest you just open it up at this level, have a little play with it, and you'll see that it's actually quite straightforward the way that it works. And if you're not happy with the actual look of it, you can always move the components round about to suit yourself, okay, to make it look the way you want it to look. So let's have a look at this little value here, and we'll see where this input value comes from. Now, if you head up to the top level, let's have a look and see where that extra control line came from. So that's the UL line here. Now, we didn't have any more space available here within the microcoded ROM, and we needed an extra control line. But we did have space within the ALU. So if you go into the ALU, you can see here that we actually have a couple of spare places. So this value here is now spare. It was originally connecting up to another adder, but I took that adder out because we already have an adder here anyway. So I could then use this value here as that spare control line, which tells us to pass the value from the graphics card onto the bus and out to the display. So all we have to do within the microcoded ROM under the 4 ALU lines is to pick the value for this particular input to the decoder of our ALU. So that gives us our extra line of control, and we can add that into the microcoded design of our pixel command. So if you follow that, you can see that that point there then runs down and into this unit here, and you'll see it actually runs into the other graphics card as well, because we use the same line for that one. So that's the basic setup. It's been quite a long video and maybe difficult to understand. Best thing to do is open this up and have a little play with it. It'll all become really clear whenever we go into the next video and we will look at the actual command. And then over the next few videos we'll generate some nice code and we'll see some the graphics actually working. Thank you for listening. I'll get you in the next video. Goodbye.